Is it started? Okay, recording pending. Okay. Okay, it started. Okay, let me just do a quick introduction. Hello all. Welcome to Automation Study Group. We have David Okiyod, who will talk about how attackers exploit containerized workloads. And so just a quick summary, right? Containers have been around for a long time, and recently they have become commonplace within the enterprise. And Azure platform continues to extend services that we can use to host containerized applications. And in this session, David will be going over Azure containers, container security, and techniques that attackers use to exploit containerized workloads. And just a quick note again, today's session is open to outside attendees, so don't share any confidential information. All right, go ahead, David.
No problems. Thanks very much for that lovely introduction, Claudia. I hope you can hear me. Can you hear me? Is it coming through?
Yes.
Yeah, nice.
Catch you, David. Yep.
Yeah, no problems. And thanks very much, Leo. Also, thanks very much for the invite. Really appreciate that. So I've known Leo for quite some time now, and it's always been a pleasure having a conversation with him. So, quick information about myself. So my name is David Okeyode. So my last name, I've heard it pronounced as Okidoki, Okiyode. I'm not too fussed about that. So you can just call me David. I'm good with that. with that. So I'm a cloud security consultant. So I do work for a company called Palo Alto Networks in the cloud security division, the Prisma Cloud Security division. You may have heard that we recently acquired a company called Bridge Crew. So which specializes in shift left security when it comes to areas of DevSecOps and securing the pipeline. And so we're really excited about that. So in Microsoft Azure MVP, I've got a bunch of Azure certifications. I'm a Microsoft trainer. I deliver Azure training all the time. I'm very much passionate about Microsoft Azure. I love the platform itself. I also dabble into AWS once in a while. So I have the AWS Security Specialty Certification and the Azure Security Engineer certification. Anyways, those are my social media handles in case you're interested to see some of the things that I get involved with. So quick information about the agenda of what we go through today. So I'm not sure how familiar people on this call are with Microsoft Azure. I assume that we have a lot of Microsoft people, so you're familiar with Azure. So maybe some of this initial part, I'll probably run through them and not spend too much time on them. So whatever demonstration I'll be showing today, I'll be doing in relation to the Azure Cloud Platform, because that's what I focus on mainly. So talk about cloud native security model, talk about mapping vulnerabilities. I'll share some things under the mapping vulnerability section about attack frameworks. There's so much that we could get into. We won't be able to get into everything today, but hopefully I have some slides that I'm going to bring up. So it's like an evolution of the attack threat matrix that Microsoft shared a while ago. So I just added some of the other techniques that I've seen in the industry, and I've just added it to make it more complete. I've got some demonstration to show you around exploiting ACI, so people deploying workloads on Azure container instances, and also I'll just talk about container security in general when it comes to Azure. I'll show a few things about defending also. So whenever I do talks like this, my main focus is on security. I tend to focus on the offensive side of things, and that's by design. That's for good reasons. So in my own opinion, I think there's a lot of lovely, wonderful presentations already out there when it comes to best practices, right? So you want to learn how to use different tools in Azure Security Center and all the other tools. Amazing presentation out there already. There's no need reinventing the wheel. Repetition is good for knowledge, but there's no need repeating the same thing over and over again. You can always find those amazing talks out there. So the other thing is that understanding attacker behavior is an important part of cybersecurity education. And the way someone put it, and I really loved what they said, was when you're architecting solution or you're developing or building solutions, you're building for users, you're architecting with your users in mind. And very few people see attackers as users of their systems. And if we were to adopt a little bit of that mindset where we see attackers as users of our systems, maybe that could have a little bit of impact in some of the ways that we put together architecture and our designs and our development. because whatever you're working on, an attacker is going to be looking at it, and they'll be looking at it with a different set of eyes. Again, another person said it in a lovely way. They said when administrators or engineers look at platforms, in many cases, they look at it at that as list, whereas when attackers look at the platform, they look at it in terms of graphs, and they look at how things are connected and how things could talk to one another. And that's sort of like the approach that's taken. So it's also important to learn from the failures of others. There was a recent popular attack with regards to like the SolarWinds attack that was really popular. And one of the things that not only the security industry, but just the general technology industries as a whole, what we're trying to figure out is how did that happen? I was reading something about an intern some while ago. God bless the intern. So anyways, so want to figure out what happened, right? So as not to repeat the same mistake. It's an important part of cybersecurity education. That's why we have disciplines like ethical hacking and offensive securities because of that reason. Microsoft themselves have pioneered the whole concept of red teaming and again, having an attacker have a look at your systems to see if they can find holes in that. So quick overview of the Azure Cloud Platform. So I won't spend too much time again because I am assuming that a lot of people already know this information. So I'll move through this very quickly. So the Azure Cloud Platform is not just one cloud, it's actually 4 clouds, right? So 5 if you include Azure Stack Hub. So you have the Azure Public Cloud, you have the Azure US Government, you have the Azure Germany, and you have the Azure China cloud platforms. They are isolated from each other logically and physically. And they have different API endpoints in terms of interacting with them. If you're interacting using client libraries, there may be some changes that you need to make depending on which cloud platform that you're interacting with. So there are multiple regions that exist for each of them. Microsoft are rapidly increasing that. They've announced 11 new regions, a lot of them in Europe, so excited about that. And also, we have the Azure Stack Hub where customers themselves can do self-hosted Azure with a similar set of API, less capabilities, less service support. But if customers want to do self-hosted private Azure environment, they can sort of implement the Azure Stack Hub. And quick overview also of the Azure Organization structure. At the top of the Azure Organization structure, we have what's called the Azure AD tenant. So the Azure AD tenant is where all the authentication takes place. So that's the identity provider behind not just Azure, but other Microsoft Cloud services and any other cloud services that a customer is connected to it. But inside Azure AD tenant, we have users, we have groups, we have service principals, which are application identities, and we have the managed identity, which is you can loosely call it a resource identity, the identity for supported resources in Azure. So that's what we have at the top of the hierarchy. And underneath that, we have the root management group. In the AWS world, that's what they'll call the root organization unit. And that's something that's not enabled by default. So that's something that needs to be enabled if you're just starting out on the Azure Cloud Platform. But under that, you can have child management groups, which allows us to simplify the governance of the subscriptions. And under that, we have the actual subscription themselves, which are where we deploy our workloads and our resources. And we have resource groups, and then we have the actual resources, which are instances of Azure services that we're implementing. I think the last time I checked, there's over 171 services now, or probably even more than that. You probably know a lot more about that than I do. So anyways, how does this relate to what we're talking about from a security perspective also? Because everything is all connected and they all tie in with each other. So in this instance, we can assign Azure AD roles to give permission on the tenant level. However, there are certain roles that do allow, or that if loosely applied, an attacker could use that to pivot into the root management group and gain permission to actual Azure resources, so not just the identity provider. So roles like global administrator are things to treat very carefully, because an attacker can use that to elevate their privilege into something like a user administrator access on to actual resources, and then being able to assign permissions to themselves. Also, we have the Azure hardback roles, which we can use to give permission to actual resources in Azure. We can apply those permissions at any of these scopes. And it's one of those things to also be a bit careful about. So permissions assigned at a very broad scope can be misused if that's ever compromised by an attacker. So, and to give a quick overview of what the permission structure looks like. So permission structure, we have the actions and the data actions. So actions are where we determine or where we define the permissions of what a user can do at the management plane of Azure. Data actions is where we make that definition of what people can do on the data plane of some of the services in Azure. And again, that has a big implication with regards to security, because what that means is depending on the role that you've assigned to a user, that could potentially give an attacker permission into the data plane of certain services if that were to be exploited. So there are other other configurations that we can do. So things like not actions to restrict some of the actions of what can be done. So that being said, I'll skip the next slide again because I think that's probably something that you're already aware of. So I'll skip that and I'll just jump over to this other one, and we'll get into the other topic. So when we talk about containerization in Azure or containerization in general, we're talking about three main things, right? We're talking about building the container images, storing or shipping the container images, and we're talking about runtime. So we're talking about building container image in the context of Azure, either using a Docker host to build that. You're building that in an Azure pipeline. So many tasks exist in the Azure pipeline that can use to automate that in a continuous delivery process. Or we can use something called the Azure Container Registry tasks, which, depending on the sort of implementation that you have, could range from single image building where you package the code, you package the Docker file, you send that over to Container Registry tasks to build your image for you, or you could even use that to automate things like the patching of the base images in your environment. When it comes to shipping, we have the Azure Container Registry, of course. When it comes to runtime, Azure has support for services that don't have orchestration support and also services that have orchestration support. With regards to services that don't have orchestration support, we're talking about services like virtual machines, container instances, which I'll show you some demo on that, app service function, Azure Batch. So all of these services and probably more allows us to be able to run our applications as containers on some of these runtime services in Azure. Then with orchestration, of course, we have Kubernetes service. All cloud providers have Kubernetes, managed Kubernetes service. Microsoft has Service Fabric, which is still there. And there's also Azure Red Hat OpenShift, which is gaining in popularity a little. I'm seeing that a bit more and more showing up in the community. So those are some of the options that we have. So let's go to look at the container security model, and let's try to understand the context of security and what we're talking about. Modern application and containerization in the enterprise today, which we see a lot of distributed application. It's very complex from a security perspective, to be honest. And one of the reasons why it's complex, you see that on the slide. So because we have multiple security models that we are dealing with, and in many cases, those security models are managed completely differently, and they have different ways to control and govern them. So a typical modern application we're talking about, you have your application, you have your code written in multiple languages today, and that code is typically running within a container these days, right? So there's still monolithic applications, lots of them, that's not going to go away. And there's still lots of cases where code is running directly on virtual machine host and all of that. But more increasingly, you have your code running within a container image with multiple container runtime options. And that container, that container is running on a node, which could be Linux or Windows. And that's managed by either a service, which is a platform service, like some of the services that we talked about, or that's managed by an orchestrator service, that Kubernetes, OpenShift, Service Fabric, any other orchestrator that's out there. So, and then we have that running on a cloud platform. That could be Azure, AWS, or GCP. So that's sort of like the models that we're dealing with when we're talking about the cloud native security model. And this is where you see like where some of the issues begin to creeping, as I mentioned earlier, because it's very important when we think about containerization security, not think about things in isolation. When people talk about that, sometimes it gets really boring, to be honest. Sometimes when people just focus mainly on just assessing the vulnerability of the images, that's great, that's good, and you do that as much as possible. And that has to be part of something that you have to get right? You have to shift those processes to the left. However, you have to understand the intersection of risks that occurs between all these different models that we're referring to. Because a malicious user that's able to gain access at any of this model can essentially move across to the other models or to the other layers. So a typical example of that is reader permission on the Azure platform level allows an attacker, if an attacker has reader permission, to be able to pull down images from the Azure container registry on the service level and to be able to start hunting for credentials within the image. And that's, again, something that's very common that many people may not be aware, that a reader permission in Azure has that permission to be able to pull down images, and then people can start hunting for credential across. And it's the same way where you could assign things like managed identities to your containers or to your pods that's running on a service in Azure, and that token could be stolen and then be used to make API calls to Azure Resource Manager or other things like that. So it's important to understand that. So when we talk about things like mapping vulnerabilities, and apologies for going quickly today, again, I've got my social media handles. There's a bunch of content that I'm currently putting together when it comes to container security that will be going on my YouTube channel at some point. So just working on some things in the background. But when we talk about mapping the vulnerabilities across the models that we're talking about, on the platform level, we can have things like our platform misconfiguration over privileged access, platform bugs, which are fine in between, but they do happen. And there was one that was talked about the last time, where a bunch of checkpoint researchers found something that allowed them to be able to escape certain services, and that was, of course, reported, and that was quickly fixed. Because Microsoft takes security very, very seriously, but they do happen. So even though they are far in between, they do happen. So then on the service level, people can misconfigure the services. They can overprivilege the services. On the orchestrator level, we have orchestrator misconfiguration. You have hardback gaps. Again, if you have a look at the outback structure of Kubernetes, that's something that you can write half a book on just understanding the models and understanding how to design that correctly alone. So it's not something that's relatively easy and simple. And it's usually you find that misconfigured in many environments. That's at least that I've seen. You see that's highly misconfigured in many environments. When you look at Outback on the orchestrator level. On the OS and kernel level, you still have your kernel box, you have your file permission levels, you have your operating system misconfiguration, you have your library, third-party library vulnerabilities that still exist. They are all not going away. And on the container level, you still have things like people exposing secret, root privilege, or overprivileged access, vulnerable images that people are pulling down from registry, insecure networking, and not implementing microsegmentation. And on your code level, you still have all those lovely issues of SQL injection and cross-site scripting and remote code execution and all of that stuff. So they still exist and they're not going away. So talking about things from the perspective of an attacker, Microsoft put out this document a while ago. So that was in 2020, that was in April 2020, they put out this document that sort of lists what they call the Kubernetes attack matrix. And it's a nice document because it gives an overview of the different objectives of an attacker in the environment and different methods that an attacker can use to achieve that. So building on this, I've just taken some of that and I've added a few more things that I've seen in the industry to that. So which is why I typically use this other slide. And where I want you to look at this as the objectives that an attacker is looking to achieve in an environment, in a container environment in this context. These are the objectives that an attacker is looking to achieve. So the objective could be, for example, initial access, right? So, and that could take any form. That could be the looking to access the API, the control plane of your Kubernetes cluster. That could be gaining shell access into a container image. That could be gaining access to data of a containerized application or containerized workload that you're hosting. That could take any of those forms. That could be getting access to the configuration stuff, Kubernetes, the etcd stuff. It could take any form, but whatever form they're looking to gain initial access or a foothold into the environment, and maybe they're looking to execute code in the environment, they are looking to persist the activity in the environment, and different techniques. That's what this is listing at, different techniques that attackers could use to try to achieve some of those. And I won't be going through all of these in details today. So as you can imagine, you could spend a long time. But this is part of the plan of what I plan to start going through some of these and showing in actual demonstration how some of these methods work and how attackers perform them in environment. So I'll be putting out videos of those on YouTube over time. So I'll focus mainly on like the initial access parts today. I'll talk about some other container security concepts, and that'll be the rest of the conversation today. So starting first with like the initial access and just having a quick look at that. So again, this is where an attacker is looking to gain a foothold in the environment. And the first method or first technique listed there is a compromise of a cloud credential, and then using that compromised cloud credential to exploit containerization services. I'll come back to this slide, but if you're interested in seeing some of this, so I actually have two presentations out on YouTube that I did at different talks where I showed two different methods already. So again, I think if you just search for container and security under my YouTube channel, you see some of those. But the one that I want to point out is, so for example, one of the popular things is there's also malware that actually focused on this, stealing Azure credentials from admin workstations. So the malwares that specifically target that and stealing Kubernetes credentials. When an attacker authenticates to Azure AD, so typically you have like that cached credential, whether that's on Windows or on Linux, they have different location. And that those access token by default, it's 24 hours by default. So the duration of that access token that's cached. And again, we've seen increasing malware where malwares that infect systems are looking for those locations to exfiltrate those credentials. And depending on how things are configured, could allow an attacker to be able to make calls to Azure Resource Manager, and then people begin to look around again in places like Container Registry and looking around to see what they can find and what they can exploit there. So that's the situation with this ACR exploit privilege escalation scenario that I mentioned again, which we see a lot of, where an attacker is able to use a remote code execution vulnerability on a service that's hosted, not on a service, on an application that's hosted, and gaining reader permission, and then using that reader permission to find, or essentially to enumerate all the container registries in that subscription, pull down all the images in that subscription, pull down everything, and found about one or two service principal identifiers in those images, and then begin to use that to carry on with the chain of the attack. So again, these are things that we've seen in different users environment in the past. So let me go back to that and let me talk about some other stuff. So compromised images with backdoor. So that still happens, right? And that's not going away. This is where a lot of people tend to focus their attention, and for good reason, because there's been a lot of issues in the news with people that have misconfigured their Docker hosts. They've exposed it to the internet, attackers scanning those Docker hosts, downloading vulnerable images on them, and then using them to progress in the attack chain. There's a very interesting one when it comes to that. So threat researchers at Palo Alto, which is the company that I work in, found a worm that was specifically targeting Docker hosts, so-called globoid. And what worm was doing, so it was a cryptojacking worm. So the attacker had some vulnerable images hosted on Docker Hub, and they had that hosted on Docker Hub, and they were scanning the internet looking for misconfigured services, which may or may not be cloud hosted, pulling down the images, and the images will send reports back to a C2 server on the CPU usage, the memory usage of the apply, or what memory that's available and CPU that's available on the system. But what it also now does is they use that compromised host as a launching pad to attack other hosts on the internet, because the attacker can then begin to send IP addresses down to that compromised Docker host that has containers running with the compromised container already installed. And when it downloads that IP address, it begins to make calls to other hosts that are misconfigured, and it begins to infect them, so that if people were tracing things, they will trace that back to the victim system, not to the attacker themselves. So, and then it spreads that way. I think it infected about 2,000 users before that was initially detected, and Palo Alto reported that to Docker, and they eventually took down the image, and that went down. So, and if you have a look at what the image was doing some very funny things. When it deployed initially, it didn't really have that much payload in it, but it's going to pull down like 4 scripts. So it had like 4 scripts that is going to pull down, and the 4 script had different purposes or different things that they were doing on the system to try to evade defenses. So, and after it successfully executed those 4 scripts, and it begins to do crypto mining, and again begin to infect other hosts. So that's not going away, that still exists. So that's the reason why things like scanning our container images is important. When we talk about scanning our container images, it's important to put that in place across your entire application lifecycle. And that is talking about putting that in place from all the way from build time to runtime. I know you've probably heard about this, too many times already, but it's important to still remind you that that's a critical part of things. So as a developer, you should have that in your tool chain if you're building any images, to add that as part of like your normal assessments that you do whenever you build your images. What I'll do is I'll try to bring up a few things, and I'll just show you an example of how that could work. So let's say this is my dev system and building container images. Before I begin to select things like my base container image that I'm going to be using for my applications, I'm going to do a quick scan. So it's part of the things that I do now. I pull down any image. The first thing that I do is I do a scan of that image. And there are different things that I'm checking for in the scan. I'm checking for vulnerabilities, right? That's normal, all the dependencies, and checking for all of that. But also it's checking for things like malware, right? Doing malware scanning, because many people may not know how important that is. Checking for things like malware in that, and also checking for other misconfigurations that could be exploited. There are multiple tools that you can use out there. The tool that I'll be using in my own case is the Palo Alto tool called Twistlock, because Palo Alto bought the company called Twistlock, and Twistlock has a tool called, Twistlock adds a tool called, so if I go Twist CLI, so it has a tool called Twist CLI that can be used for that. So, distributed to developers in the environments, they can just do ad hoc scanning anytime. So I've got a bunch of images that I need to select some on. So if I do Docker image, let's say I'm trying to make a determination as to which of these to use. I can do a quick assessment of both of them. So let me go ahead and grab those. And here's what I'll do. Let's clear the screen. So I'll do a quick scan. I'll send that to my Twistlock console. I'll send that with an API token that I generated earlier. And I'm going to send that image to assess it against organization baseline before I even begin to think about using that. So if I run that and it's come out with certain results, so because I specified the detailed parameter, it's giving me detailed result, but I can just say give me the summary of whether the image I'm about to use, whether that passed my organization baseline or not. So in this case, it's showing me that the image that I'm planning to use has failed the organization vulnerability baseline, but it also failed the organization compliance baseline. And if you go have a look at the things that I'm checking for in this case, So if I have a quick look at what I'm checking for, so I'm checking for things like just normal vulnerabilities, but I'm also only checking for vulnerabilities that there are fixes available for. So there's no need informing me if there's no fix for that. So, and alerting and anything that's like that medium and above and the other stuff. So this is the policy, or not this one, it's this other one. Let's go to CI. And if I go, that's the policy. So this is the policy that I'm using to assess that. And again, that's governed at that level. But I also have a compliance policy that I'm using. So I'm within this compliance policy, I'm going to be checking for malware that could be hidden in the image, backdoors, crypto miners that could be hidden in the image, but also mistakes that developers could make. If you have sensitive information that's being stored in the image, it's going to be checking for those private keys that may be stored in the image. Again, crypto mining binaries that may be stored and other sensitive things. I can even construct my own custom assessment, which I've done in this case. Right, I've constructed just a simple script that's going to be assessing certain files and look for certain files in my images. If it finds the file, it's going to mark it as not. And again, I could be as complex as possible. That's just making that simple. So what I'll do is if I clear this just to show a little bit of that also. So if I make a mistake of accidentally adding important credentials to my image, let's go add some dummy client ID and secret key here. So go embed that, and if I go to build this, I'll go ahead and build. Oh, actually, you know what? I think I don't want to use this because that would take a long time to build. It's got quite a bunch of stuff in it. So what I'll do is I'll go use another one. So this one is more simpler, and I would go ahead and make some intentional mistakes on this. I'll go ahead and build that. So that won't take long. The other one will have taken quite a long time. So, okay, so Docker images. So I'm going to scan this node app. And again, this is ad hoc scanning on my machine as a developer. So if I do node app v1, and you can see that it's detected that hey, you've got sensitive information in the variable, and that's failed the organization policy. So I'm not even going to proceed with that. Of course, the best thing is to do that again also the way at dev, at the authoring stage, do that in the registry, do that in your pipeline before they get to the registry. That's very important. So I'm not going to run this because it's going to take a long time, but I'm going to show you an example of something like that. So it's important to have these processes going forward. So in this case of a pipeline that's building, so it's going to use some Docker Compose file to build a bunch of containers that's going to use the code that's committed to that repo to the master branch. And one of the steps that I'm doing is that before I go ahead and push that to a container registry, I'm going to do a quick assessment of that. So not just at authoring, but I can do that. So this helps to reduce bad images in the registry before they even get to the registry. That stops it from getting further there. Right. So, and again, if I run that, it's going to take a while to complete all of that. So I believe that I've got previous runs that I could potentially show some of that. So here's an example of that where I'll just try to maximize that a bit, where it's essentially done the same thing that I've done, but essentially it's using an extension that I've downloaded and installed and pointed it to my console, and it's used that to say, hey, you failed the policy, therefore it's not going to push that image into the registry. And this again helps developers to fix that issue before it goes further. So anyways, let me move further to talk about other things. I'm looking at the time here, and let's go further. So other things that could happen for when we talk about initial access are stolen configuration files, right? So again, it's similar to what I showed you on the Azure front earlier. There's multiple malware that's targeting that. There was one that came out recently. So there was one that I was reading about recently that specifically was targeting kubeconfig files on administrator hosts. So whenever it infects an administrator host, it's looking for kubeconfig files and using that to gain unauthorized access to the Kubernetes cluster. Application vulnerabilities are not going away, which is why the assessment all the way in the lifecycle is important, including at runtime. That's important. It's including at runtime. You're assessing that at runtime. I'll talk about runtime security in a few more minutes when it comes to container-sec. So exposed and misconfigured dashboard. So this was what happened to a popular car manufacturer in the US a while ago. So dashboards, and this can also be a bit complex because Kubernetes is quite extensible and people are pulling down all these extensions and utilities that can help to that provide some effectiveness without knowing in some cases that those utilities have deployed some dashboards that's exposed somewhere, right? So we've seen a few of that. where that's happened. And so it's important to really understand what you're deploying and what you're running. Again, it's even much more important if you're assessing those as part of your ongoing process through your pipeline. So you're assessing your Kubernetes manifest files before they ever get deployed to see if they are not just checking them for, again, not just focusing on just the vulnerability side, but also checking if they are misconfigured. Checking those templates if they are misconfigured is very critical. I'm not going to go into too much details, but the 3CLI tool that I was showing you earlier, also, if I go to 3CLI, you know what? It's probably easy for me to type it. 3CLI. So it can also scan the IAC files, including Kubernetes manifest files, and do assessment of the types of configuration. For example, if I have overprivileged permission and all those things before moving that IAC. So it's not just about the images, it's also going to check those sort of files. So unsecured data Docker daemons, I already talked to you about this. So I'm looking at the time now. I got a few more times and I want more time for questions at the end. So what I'm going to do is I'm just quickly going to, again, if you're interested in seeing about the rest, I'll be putting out content focusing and trying to demonstrate really how attackers go about performing these techniques in a different environment, and just showing some of the things that I've seen and some of the things that have been documented by other security people in the industry. So again, we won't be getting into all of them today. So let me pause there and go talk about runtime security to bring all of this to a close. So when we talk about containerization and when we're talking about concepts like DevOps and continuous delivery, it's very easy to think, yeah, you know what? There's some traditional security concepts that we don't need. And unfortunately, some may have the assumption in their mind that runtime security is no longer important. So that is really, really poor way to see things. I'll give you an example. If you look at the case that happened with SolarWinds, with the last attack and the last thing that happened, the only customers that really were able to come out of that unaffected were customers that were looking for signals or threat signals at runtime, because this was a legitimate file from a trusted publisher that's now found its way into your environment, that's now receiving command from intelligent people that know how to evade defenses within your environment. If you're not really looking at signals like network signals and process signals and file system activities, if you're not looking at all of those, that because all your defenses will have said, yeah, that's trusted, that's all fine. Whatever it's doing, that's all good. You have to look at whatever it's doing. But then the question comes in an environment like a container environment where we're talking about massive scale. How do you translate all that capabilities, right? Because that's the issue in terms of managing that at runtime. How do you manage all that stuff at runtime? That's where machine learning can be of help, right? So some of those can be built into like machine learning algorithms that can make some of that easier. And I'll show you an example of that. But just keep that in mind that when we talk about containerization, apart from all these other aspects of shift left security, runtime security is important. That is your backstop if all else fails, because 0 days will not go away. The kind of things that happen with SolarWinds, we don't want it to happen again, but it is going to happen. And the only people that are going to be able to escape that unscathed are people that are looking at signals at runtime and not just relying on whatever processes they've put in place up until that time. So 0 days are not going to go away. Users will not stop being users. Admins will not stop being admins. Engineers will not stop being engineers. So some of the detection points that you want to be looking at with things like process activity, network activity, file activity, and other types of activity like that. Again, the question is, how do you implement this at scale in a containerized environment? How do you do that? Two challenges for that. There are two main challenges that are brings. Number one is that some of the services that you can use to run your containerized workloads, there are services that you don't even have access to the to the actual host where things are running. So if you're running your container image in an Azure function, you don't even have access, right, to that environment, and that's an environment that spins up serverless, right, on-demand, event-driven. Same thing with Azure ACI. Same thing with things like even Azure App Service. So you don't really have stuff in the backend. So how do you manage that if you're deploying your containers on that? So that's the reason why the demo that I'll show you on this would be using ACI to point out that even in those environments, you can still implement some level of runtime security. And then I'll bring everything to a close. So what I'll do here is I'll go to bring up this. So this is going to turn from my development machine to my attacker machine now. And there's some container workloads that I've got over here. So running on container instances again. Oh, are they stopped? No, they should be started. Yeah. Oh, no. I think there's something with the UI being a bit slow this week that I seem to have noticed. So sometimes I needed to refer. Pending. Why is it pending? It's running. Yeah. I think, yeah, the UI needs some update, something. Yeah, so they're both running. So anyways, let's go to bring up a few things that I'll do. So the first thing is that both of them are running bad applications that have remote code execution vulnerabilities in them. So again, just think about it as there's a 0 day, you didn't know about it. No one knows about it. It passed all your tests, it passed all your vulnerability assessments, it ended up in production. Someone found a flaw. Now they found a remote code execution, they're on your system. What's your backstop? That's the question that we're going to look to answer here. So the first thing I'll do is I'll go to the one that I've not implemented any form of protection on. So I'll go to that. I'll quickly set some parameters that I'll reuse later. Yeah, good. So let's clear the screen. So again, the application that's running, that container instance has some vulnerability. So it's a remote code execution that allows me to be able to run commands. So now I'm passing commands like list to it. It's running the eCloud admin console, and I'm able to list a bunch of stuff in that. So what I'm going to do here is I'm going to just use that remote code execution to open a remote shell. So let's restart. I'll just quickly log into this. So I'll use that to open a remote shell into this system. So what I will do is I'll need to, first of all, is to go config.co. I'll quickly grab the public IP address of the attacker machine. So I'll open the remote shell back to it. Where are we, David? Where are we? Yeah, let's put that information in there. And good. So what I'll do is I'll open a listener and I'll go to execute this. And that opened up a remote shell where an attacker now has, again, this is to an Azure Container Instance environment where typically you're like, I have no control over the underlying backend. But again, vulnerability, an attacker now has that. So many things that an attacker could begin to do here. So an easier one would be begin to look at the application for example, can make some modification to the application to begin to spread malware to people that may be accessing it. So the local copy at runtime, begin to make changes to that. I'm not going to open that, but can do other things to begin to look if there are other containers that are running in the container group. So with Azure Container Instance, there's the concept of container groups that are running together on the same container instance. So I can see that it's got nothing on that. So the thing is, I'll see if I'll be able to do some installation on that. So what I'll do is I'll see if I can do some installation on the Azure Container Instance, and I'm able to. Some maybe thinking I don't have access to that, but put net start on that, begin to see what if there are any other applications that's running alongside this. There you go. So this, you see that once you don't have that backstop, that means if something were to bypass all of that processes, then then there's nothing there. So I'll talk a few minutes later about how to handle that at scale. So if I go ahead and put that, I can begin to look around and see what sort of things that are running. I can do things like list all the environment variables, see any interesting information that I can find, which showing me things like service fabric over here. So that's interesting information pointing me that this is an Azure service that this is running on. Another piece of information. So if I know it's running on Azure service, another thing an attacker could do is to begin to look for authentication or access tokens that they could use to maybe pivot within the environment. So let's go have a quick look at some of those. So what I'll do here is I'll go to have a quick look at some of this. So apologies. Am I on the right system, David? Am I on the right system? Okay, 1 minute. I'll just quickly do a quick find of, let's see. Okay, yeah, found what I was looking for. Got it. Okay, so I'll do a quick list and I'll see there's nothing that's listed there. So does this even have a managed identity associated with it? Can go ahead and put Azure CLI on that and see if it has managed identity associated with it, and see if we can obtain the access token if it does have a managed identity associated with it. So that goes through, should not take too long to finish. So while all of that is taking place, again, remember this is an embedded application on an instance that I don't have access to manage the backend. Come on. It's doing something. It's going to get to that shortly, I believe. So while it's thinking about this and while it's thinking about that, not to waste too much time, what I'm going to do is I'm going to show you a defense side of that, and I'll show you an example of that. So in this case, I'll be showing you the defense when I'm running something called app embedded, which essentially I have this containerized application that's running, but it got something that's embedded in it that allows me, even in this sort of environment where like Azure Function, like App Service, like Azure Container Instance, I can still provide some level of runtime security on it. So I'm able to do that. And again, that's something that can be automated in a pipeline. So one of the tasks that I can add when I added the extension that I added earlier. So if I go back over here and I go to edit my pipeline, one of the tasks that I could add if I search for Prisma is the embed. So I can build my container image and automatically embed whatever I need to embed. Again, I don't need to do this if I'm going to be hosting my container on AKS and other stuff. So all you need to do is to deploy a daemon set at that point. But if you're going to be deploying again, in this sort of environment where you don't have access to those sort of environment, you can still have some level of runtime security is what I'm saying. So that's what I already have on that. Again, that can be put in through the pipeline. So what I'll do is I'll go under defense, I'll go under runtime, and I'll go configure an app embedded policy to show you what that looks like. So one of the first things that to mention is if I go on the monitor on the runtime, if I'm hosting my container runtime that's supported, what this will actually do is that it's going to learn about what that container image is meant to do, and it's going to automatically build a model for it. So for example, it's going to learn about the processes that this is meant to be running. It's going to do both static and behavioral analysis. It's going to learn the sort of network connections, that network port I should be listening on, or what network connection I should be making, what path on the system that should be mounted, that I should be writing to, and anything that deviates from what it's learned, because that's what a container image typically just sticks to what it's meant to do. It's going to alert and say, okay, you're moving away from what you're meant to be doing. So that's what this can also do. But in this case, I'll just go ahead and set that statically very quickly. I'm running out of time here. I'll just quickly say runtime policy, and I'll say allowed processes app.py loud and Python loud, and I'll just set that to alert for now. I can prevent that from actually even running. I can prevent things like crypto miners and other things from running. I can do the same for network and say, if you begin to make any type of dodgy connection, that can be stopped even on the DNS level. I'll just go ahead and save that. So I've got a name for that. I'll go ahead and save that. And what I'm working on, I think that's now finished. So what I'll do very quickly is I'll see if it has a managed identity. I think I lost my shell. So let's bring that up again. Let's run that and see if that does anything. Okay, so doesn't seem to want to play ball on this one. So what I'll do is, rather than spending too much time, I already showed you. So I already showed you the main thing that you need to understand here. Let's go to that here. So I already showed you like the main thing that you need to understand there. So yeah, there you go. So that was what I was going to show, that I've been able to pull down the access token, can zip this up, send that over to a storage account somewhere. Or the other thing that I could do is I could just download Storm Spotter, which is a tool that was created by Livon at Microsoft for red teamers. Run Storm Spotter, do an enumeration of the Azure subscription, take that information for analysis somewhere else. So, but what I'll do is I'll show you the runtime security part of that. And to do that, I'll go get another system. So, and let's go back to that's the one that I've got some protection configured for. And I'll modify that to 199. And I'll go ahead and try to run. You know what? I'll just go ahead and bring that up again on my system and run that quickly. So I've modified that. Let me go to run that. So that's still successful. However, what will happen is if I go on the manage, go on the defenders, copy that information, go on the monitor, go on the event, go on the app embedded event and filter for that event. I can see that information right there. It's like, hey, there's somebody that's running lists on your system, and that's because I set that to alert. If I go ahead and modify that, and I go ahead and set that to say prevent that from running anything from what's meant to be running. And again, remember that this is something that can be automatically learned. And then I can go to run that again. Now you see that that's no longer successful. And that's, if I go back to have a look at that, that's something that will have been prevented by the system. So it will have prevented it from running on that. So now that's no longer successful, and that's stopped. So I'll stop there. So apologies for going too much time over time, because I want to be able to answer some questions. So quick takeaway for today. So remember these two images. just keep these two in mind. Remember the intersection of risks, and remember that you have to look after all this intersection. And also remember to understand methods that attackers use to achieve their objective in a containerized environment, and make sure that you have considered those when you're architecting your containerized workloads. Thanks very much, and I'll stop there.
Thank you so much, David.
No problem.
Great presentation. Do we have any questions?
That's great, David. It's just lots of information, need to process it. And by the way, somebody else here also in the chat, if you could share the slides with us.
Yes. So I believe that I actually have the slide on my GitHub repo already. Yes, but if that's okay, I can send that to Claudia and yourself, and you can share that and put the link somewhere.
Awesome.
Yep, absolutely. And I will make the recording available on our Automation Study Group channel, internal also on stream.
Yeah, no problems. No problems at all.
Yeah, and if anyone interested in presenting, please let me know. We're always looking for presenters.
Okay, thanks very much. Really appreciate the invite. I'll stop sharing my screen.
Let me stop the recording.